Hello guys, how are you doing? I hope you are doing very well. Okay guys, today we're gonna talk about the circuit diagram. What does it mean? So, what is circuit diagram? Why is it important? So, Bismillah. Circuit diagram is a diagram that shows the components of a circuit by signs or by symbols. It means to design something, design a circuit. We are going to design it by diagram, and it's going to be easier designing this. So it's gonna be easier. Like instead of drawing or something, the pictures it's hard. So we have some diagrams. You see here some symbols in the diagram that you can make it like that. Then you can start to make and do your job. That's why it's important, the circuit diagram. So first of all, circuit diagram is a diagram that shows the components of a circuit by symbols. Okay, we have, real things, but by symbols. We are going to see them in the diagram. So if you see that a 1.5 cell battery is here, like this is the diagram for this, the symbol for this. And if you join two 1.5, it's gonna be 3, right? So that is the symbol for this. And the 3 battery, not to join it, it's one battery, which is 3 volts. This one, guys, this one might be somehow complain, but actually you can just separate them by this one because it's two connected. You see here is the line between these two has been connected, but in here we don't have this line that has been connected. It means it's only one, there's no connection. We don't have two battery that has been connected. In here you see between these two, leave these two that has been flipped. You see it's two T's here that has been flipped, but in these two we have two more lines, parallel lines there. But between this one we have a, a line which is connect these two. What does it mean? So easy to understand, that two cells connected. But in here we don't have this connecting, means it's only one cell. It's still like this one, it's 1.5, and 1.5 is gonna be 3 battery. 3 volt voltage battery. In here also 3, but the difference is this: two things connected, two cells connected, we have a connecting line, and here we don't have it, so don't confuse this. And the wire, connecting wire is easy, just a line. And bulbs, or we can say lamps, it's exactly like that, so easy. And you see that it's these two has not been connected. That's why it means this is open switch. Okay, this is open. You see it has been opened. It's so easy to recognize this. And also the closed one is means it's closed, there is no space. You see here is a space, you see, but here there is no space. That's why we say closed switch. And here is a buzzer that it's like kind of different from the others. And the motor is like there's an M inside it. It's also easy to memorize it. The motor is here, the buzzer, and closed, you see there is no space, and open is here, switch. The bulb is different from the others, and the connecting wire is only the line. And the cell is also easy, two T's that we said, letter T, that one is large, one is small, that has been flipped. But these two, don't confuse between these two. We said because two 1.5 connected, we have one line, it's connecting line. But because it's 3 but there is no connecting, we don't have this line. So guys, when you make the diagrams, you will make like this. For example, in here in circuit A, what do we have? So if you know these symbols, what are these symbols for each real component? So you have to know. For example, we have studied that this means bulb. If you see this directly, you have to say there is a bulb or there is a lamp in this diagram. So it means we have a bulb, a lamp here. And the wire, you see that we said the lines around it is going to be the wire. So we have a lamp and wire. What else do we have? You see there's a switch. Is that open switch or closed? It's closed. There is no space like this one. Closed switch. And what is the T and other T we said? With letter T that has been flipped. You see T and another T, which is, it means 1.5 cell, guys. So that's how easy it is. And circuit B, we said the lines are connecting wire, and we have switch. Which switch is that? Open switch. You see it has been opened. And this is buzzer that is completely different from the others. You can just notice this easily. And we have the battery here. How do you know which one is that? We said because it's like complex, not simple like that. It means it's not 1.5. So it's gonna be between two things: two 1.5 or one 3 by 3 V battery. We will say it's one 3V battery. There is no one to 1.5 like this one. How do we know? Because between these two parallel lines, we don't have a line for connecting them like this. You see, no connection. It means we don't have two cells that has been connected. It's only one cell, but it's 3V battery. Okay, I mean like it's one battery, not one cell. So in C, diagram C, you see we have two lamps here, two lamps, and also connecting wire, like we said, connecting wire, two bulbs or two lamps. And what's this? The simple one, 1.5 cell. So easy. That's how easy it is, guys. I said it's easy. In here too, guys. First of all, I'm gonna mention the name of the companies, then I'm gonna say something else about this. In A, B, C, in A, we said we have a buzzer, a wire, of course, and also closed switch. You can see closed switch, and the simple one is what? 1.5 cell. So B, a buzzer 2, closed switch 2, of course wire, and we have two 1.5 cells connected. How do you know that it's not 1.3 V-Bar? How do you know that it's two 1.5 connected? Because there's a line connecting them that has been connecting them. So, and also C, we have a buzzer, an open switch, wire, and two 1.5 cell connected. How do you know this is connected? Like we said, because between the two parallel lines there's a connecting line. That's why we say it's two 1.5 cells connected. Okay, it's not 1.3 V battery. It's okay, it's 3 volts, but not one battery which is 3 volts. It's two cells connected to make 3 volts. Guys, in here we have to know something. I'm gonna tell you that which one is working, which one is not working, and why. This one is not gonna work. Why? So the switch is closed, the buzzer is here, then the battery is there. So buzzer needs more than 1.5 volts. Buzzer needs 3 volts, okay? So if you see something like that, you have to say this circuit is not working. Why? Because we don't have enough amount of electricity. It's 1.5 volts. We need 3 volts for electricity and for buzzer to work. And in here, B, we have two 1.5, which is 3 volts. It means it's enough for buzzer. And we have the buzzer and the switch is closed. Is that working? Yeah, there is no problem. The electricity will move around. The switch is closed and it's gonna go for the buzzer and it's gonna work. So it means B is gonna work, A is not gonna work. Let's see what about C. C, we have 3 volts by two connecting 1.5 cells. And also we have a buzzer, we have open switch and wire. But this one is working or not? It's not gonna work because the switch is open. It means this wire is not connected to the next wire, because in here there is something cut. I mean the wire is cut here, okay? The wire cut here. Why? Because the switch is open. When the switch is open, it means this switch has not connected the left wire to the right side wire. You see, left side to right side has not been connected. Why? Because the switch is open. So it means electricity is not gonna go for the next one to the buzzer to work. We have enough amount. In here it's closed, but we don't have enough amount of electricity. But in here it's we have enough amount, but because it's open, the electricity will not go for the buzzer. So that's why it means it's not only knowing the diagram. In here, for example, B is not gonna work because the switch is open. In this one, we have 1.5 and bulb. Bulb needs only 1.5 cells, so it's gonna work. The switch is closed. we have enough amount, so the bulb is gonna work. In here, it's not gonna work. Why? We don't have switch here, but we have 1.5, but we have two bulbs. I mean, they need three bulbs. Guys, in this, for bulbs, actually, we can say it can work, but it's not brightly. You know, it's dim. The light is dim. So, it's not gonna, we can say it's working, but there's no, I mean, it's not bright. The light is not bright, so we can say it's not working. That's why I say, otherwise it's working, but the light is not much. And guys, we have two types of circuits. One is series circuit, one is parallel circuit. What is this? What are these two, and what's the difference between these two? So first of all, guys, we have to know volt is the unit of measurement for the strength of electricity. Like we have the different units. For example, for the length we use meter or kilometer. For mass we use kilogram. For weight we use newton, and for any other, for temperature we use Celsius. You know, for different things we have different units, and the unit of electricity is volt. We don't say 2 kilograms of electricity, we have to say 2 volts of electricity. And that's I mean when I say, when you say unit of measurement, it means how will you measure it? By what? By volts. You say 10 volts, you say 20 volts. You don't say 20 meter, 20 kilogram, 20 Celsius so of electricity. So you have to say 20 volts of electricity. So let's go for this difference between them. Series circuit and parallel circuit. Guys, this one is series circuit. It said is a circuit that has only one path. You see, there's only one path. The wire is gonna go around and come back to the negative side of the battery. You see, there's only one path. That's it. Because it has only one path, we say it's series circuit. It's like a series. You see, one by one joined to each other on one way, on one path. But parallel circuit is a circuit which has each lump has its own path to the battery. You see, you can see each of them has its own battery. Why? Because each of them will get full amount of voltage of battery. Like you see, even if you look at here, you see this one has the path for this one, and also the next one too had its own path for the next bulb. That's the one of the difference. Series circuit is a circuit which has only one path, but parallel circuit is the circuit which each lamp has its own path to the battery. And also another difference, in series circuit, if one of the lamp doesn't work, the others will not work too. Okay, the others will also will not work too. Here the other will also work. No, actually I have written wrong here. It must be not working. So in here, you see, if I take out one of these bulbs, the electricity will cut here between these two wires. Because it's a series, it's only one path, you cut the path. If one of them is not working, you will cut the path. So but in here, if I take out one of them, so the electricity is still going for the next one. Why? Because you see, it's not gonna cut for the next one. It's continue for the next one. You see, the wire is continue of going for the next one. But in here, if I cut here, the wire is not connected to the next one. Here is gonna be space. If we have space in the wires, it means it's not working. But in parallel, each lamps, if one of them doesn't work, the other lamps are still working. We said even if we take out this lamp, the other is gonna work. Even if this one is not working, this one is gonna work. Why? Because each of them has its own path. This one is not related to this one for working, but in here, each of them is related to the next one for working. If one of them is not working, the whole series will stop. It will cut. If you look at this part, you see the whole lamps are gonna work. You see the electricity are going. One is gonna go for this one for the next one, for the other one. But even if you take out one of them, the others are working. Like here, you see, one is not working, but the other two are working. Why? Because they have their own path. There is one path for this, there is one path for this, and there is one path for this. They are not connected, I mean. But in here, you look at this part. The line is like that. If you take out one of them, you see the wire is gonna cut. Electricity will stop between these two. If you take out one of them, if the one of them is not working, it means it's burned out. So it means you just took it out. So it's not gonna work. So these are the differences. Series circuit is a circuit which has only one path. Parallel circuit is a circuit which each lamp has its own path. It's not only one path. Each lamp has its own path. But in series circuit, if one lamp doesn't work, the others will not work too, like this one. You see, one lamp is taken out, the others will stop working. In parallel circuit, if one lamp doesn't work, the other lamps are still working, like this one. You see, one lamp is not working, the others are still working. Why? Because they are not connected to each other. This is a parallel circuit diagram, guys. You see, the electricity will go from here to there, continuously will move. These are the branches. Even if we take out this one, guys, just imagine if we remove this one, what's gonna happen? Nothing. We have a wire for the next one. You see, the wire is still going for the next one. Even if you take out this one, the wire is still going for the next one. Even if you take out the last one, the wire is gonna go for these two. You see, in parallel, the lamps and the components are like branch of the diagram. You see, it's like a branch. It's not on the series. You see, if I take out this one, here is gonna cut, so the electricity will not go for the others. That's why the others will not work. If we take out one of them, it means like you are cutting the wire in series, because there's only one path. But in here, because we have one path, 2, 3, you see, we have more than one path. Each of them has its own path. That's why we say if we take out one of them, the others will still have their own path. It's not related to each other, so the others will work. In series circuit, if you take out one of them, the others will not work. In parallel, if you take out one of them, the others work, because it doesn't relate to them. And there is something extra that you have to note about this. In series circuit, because it's like one path, and the whole electricity will be divided for them. Like, for example, if we have 6 volts here, because we have 2 lamps here, each of them will get 3 volts. 3 volts for this, 3 volts for this. Because it's only one path. During this path, the electricity will go and divided for all the lamps. But in parallel, it's not like that. Because each of them has its own path, whole the electricity from there will go for this one, and whole will go for the next one. It means if we have 6 volts here, each of them will get their 6 volts. Because they are not related to each other to divide, the electricity will be divided. They have their own path to the battery. This path to the battery, and this one has the path to the battery. It means it will get its whole 6 volts from the battery, and this one is get its whole 6 volts from the battery. But in here, because it's only one path, they are related to each other. That's why the battery will divide the electricity for them. It's 6 volts, it's gonna be 3 for this, 3 for this. But in here, if it's 6 for this, 6 for this. It means one time we'll give it to this, one time we'll give the whole to this one. That's it. And that's all about the circuit diagram, and these are the symbols that you have to know all of them, and which one is working, which one is not working too, you have to know. And the difference between series circuit and parallel circuit, why is it like that? Why in series circuit, if you take out one of them, the others are not working, because you cut the wire, it's only one path. In parallel, if you take out one of them, the others are still working, because in parallel, it's not like one path, they have different paths, and they are not related to each other. And that's how the diagram is, and also how the electricity will go for them. We said in series, the electricity will divide for all of them. Even if we have 50, let's say 50 volts here, we have 10 lamps, so we'll divide it. 50 divided by 10, each of them will get 5 volts. But in here, if you have 50 volts and 10 lamps, each of them will get whole 50 volts. 50 for this, 50 for the. Why? Because they have their own path to go for the next one, to go for the battery to get the electricity. They will get whole electricity. That's all about the circuit diagram and series circuit and parallel circuit. I hope you understand everything. Best wish.